Hello student. In this class we will discuss about the classification of instrument. So measuring instrument are classified into absolute instrument, secondary instrument. Secondary instrument are classified in indicating instrument, integrating instrument, recording instrument, and measuring instrument can be analog, digital, mechanical instrument, electrical instrument, electronics instrument, man manual instrument, automatic instrument, self-operated instrument, power operated instrument, deflection instrument, or null type instruments. Then we will discuss one by one in detail each instrument. So first we will discuss about absolute and secondary instrument. The absolute in absolute and secondary, the secondary instrument can be categorized into analog instrument, digital instrument, and again analog instrument can be categorized into null type, deflection type. Again, deflection type instrument can be categorized into indicating, integrating, and recording instrument. So now we will discuss about the absolute instrument. Measure the quantity directly using the fundamental physical principles. There is no need to convert or calibration of in this instrument. They can measure directly using the physical principles. For example, electrometer measure the absolute electric charge potential differences between the electronic circuit. Operate without need to external calibration. So this instrument no need to external calibration. Another example is absolute pressure gauge to measure the pressure relative to the perfect vacuum. When we want to measure the perfect vacuum, then we can use the for absolute pressure gauge. Example of absolute pressure gauge, we can use the macleod gauge. So macleod gauge, which determine the pressure by compressing a non-gas volume to measuring indices. Look, it's the it determine the pressure by measuring compressing that volume of known ka and equal to is measuring its effect. So this we will discuss a detail when we will discuss the or industrial instrumentation. So this is a separate topic. So that time we will discuss this concept. Torsion meter measure the small force or gravitational force. We can use the torsion. So absolute thermometer to measure the temperature based on the physical property like substance, ideal gas. We can use the temperatures. These are the, for example, gas thermometer, radiation thermometer. These are example of absolute instrument. We should memorize all these things only. Plastic instrument, plastic galvanometer we can also to measure the electric charge or current directly using the principle of electromagnetic inductions. And pyrometers is also used to measure the wavelength or small displacement based on the interference of light phenomena. So mainly we have to memorize in the absolute calculator which instrument we can put. So this is the then we will discuss about the secondary instruments. Secondary instrument are devices that used to measure monitor, record physical quantities indirectly, often by relying input from the primary instrument, while primary instrument directly sense the physical phenomena, for example temperature, pressure, flow, and secondary instrument process that processes display, record data for analysis or control. So here we will discuss about the here we will discuss about the secondary instrument. Suppose that this is the primary instrument. This is the physical what the physical this is the physical quantity to be measured. So this is suppose that this is the any temperature, pressure, flow, any support temperature is there. So we can use RTD, thermocouple, etc. We can it can says and its output. This is the primary sensor. Then its output instrument that its count can give to secondary instrument. secondary SI, secondary instrument we can say it. Secondary instrument, then its output. So that this secondary instrument it take the input from the primary instrument, then it's process that signal, and there are so many operations that can be performed here: process, displays, recording, analyze. If the analyze and control all these things may be performed in second instrument. So this working principle of this is a horse in this instrument. Second, we will discuss about the example of secondary instrument. First, pressure measuring instrument. So this for pressure measurement, we can use the pressure sensor like burden tube, thermocouple, burden tube. First, second, we can use the manometer. Third, we can use the diaphragm, velos, all these things we can use a primary sensing element. After sensing the pressure, then we can use then secondary measurements instrument like digital display, recording, showing picture. All these are the for pressure measurement. Suppose that this is the primary instrument. This can be suppose this we want to sense the pressure. So this is the pressure. We want tank this tank. This is a pressure sense. That can be diaphragm. Diaphragm we can put DA. Warden tube we can put VT Warden tube. Then we can also put the velos. All things, and then it can convert pressure into displacement. Then this displacement, so then gives to secondary instrument. Then secondary can be here in case of this. It can be like LVDT, which converts to displacement into voltage. Then again this instrument processing, signal conditioning, recording, controlling, all things come here. So that process so that we can use for controllers. So in this way, this is the example how the pressure measurements. These are temperature measurement. Temperature measuring as primary may be thermocouple, RTD, thermistor, anything that which can detect the temperature. Then its output give to second instrument. That second instrument will secondary may be controller, data analog, display, regulating. All those things can be here. So we can use the second instrument. Then flow measurement for flow measurement. Primary is a flow turbine, ultrasonic, level sensor, magnetic, and so many different sensor, primary sensor we can use for here. Secondary control panel software, analyzing. Secondary same thing. Secondary things must controlling, analyzing all the process so that we involve where we can display, record, and monitor the data and control that data. So electrical system, primary voltage, current, power, and secondary a millimeter oscilloscope. Millimeters instrument we can use, oscilloscope we can use for display, power analyzer for and then instrument. So this is the up to secondary instrument. Next we will discuss about the null type and deflection type instrument. So this null type and deflection type instrument part of analog instrument. We can categorize analog instrument into two ways. First, deflecting instrument. Second, null type instrument. Again, deflecting instrument we can categorize indicating instrument, interrogating instrument, and recording instrument. So we will see the definition of deflecting type instrument. In deflecting type instrument, the measured quantity produce a physical deflection of a pointer on a scale. Measured the quantity which being measured that produce a physical deflection on pointer. The reading obtained by observing this deflection. So principle working principle this instrument operate on the principle of equilibrium between the measuring force and quantity to quantity measuring forces or restore. Suppose this is the example. Suppose this is the spring restoring the spring that restoring effect will this is the one plate is it unknown force supply here. This restoring force of this spring that balance to the unknown force and pointer will deflect and output can be displayed here. So this is the deflecting type instrument. The type of that we again type of instrument. The instrument classified based on the quantity to be measured. First, electrical instrument. Electrical quantity we can moving coil galvanometer. The principle is magnetic effect of electric current. Then application to measure a small current. Moving coil instrument that used to the generally DC applications. Just memorize these things. Then ammeter, principle of deflection is a deflection directly proportional to the current in application to measure the current in circuit. Voltmeter that also produce a deflection deflection directly proportional to applied voltage between the two terminals. Voltmeter, wattmeter to measure the power by using current. When we have measured the current and voltage, then we can multiply that current and voltage so that we can get the power directly. So that concept can use for the AC or DC. Mechanical instrument, pressure gauge, deflection. In pressure gauge, the deflection caused by the pressure applied to an elastic element. See a deflection. Suppose the pressure gauge is there, we can discuss about it. Suppose this is the pressure gauge. If pressure is applied here, pressure applies here, then deflection delta L. So here, change the deflection here. Suppose that this can be Warden tube. Suppose like this is the Warden tube. Pressure apply on here, then deflection will be here. This is the output. This is the diaphragm can be open. Diaphragm, this is the pressure apply on here, deflection so here. So that can be also the of pressure gauges. Manometer, manometer, the liquid deflection in tube due to pressure differences. So you follow pressure measurement. Suppose that this is the tube is there. This is the tube. This is the tube. We are talking about the U-tube manometer. General principle of this is the U-tube. Suppose that initial the liquid are same level. This is the liquid is filled here. So when pressure apply on here, this is the initial pressure apply here, and so this move to upward, and so the pressure here. So it's the level to increase here. Then this and this height will be, we can measure. This is the height h. So then P1, the differential pressure dP, we can write but P2 minus P1 equal to rho G delta H. Means rho is a density of fluid which is filled in gas, and G is a gravitational force, H is a height difference. When we have applied the force on this leg, so this level of the U2 another leg will be increased, that difference of height. So we can, in this way we can measure this principle of the manometer. Then again in the torsion meter, deflection due to applied torque, used to measuring the twisting. Thermal instrument, the thermocouple, the deflection caused by thermal expansion. Suppose that one rod is like this. They have two different one rod thermometer is there. The rod in expansion card difference. This is two rods is there. The one rod is made by two. So that two materials. One expansion coefficient is alpha. Another expansion coefficient is suppose that beta. If temperature we can apply, that start to bends. Bending depend on the material we have used in this. So that deflection is directly proportional to thermal expansion. So to measure the temperatures, we can use this. Another is a electrodynamic instrument. Electrodynamic instrument, the principal interaction of magnetic field produced by the current carrying coils. दूसरा application to measure the AC, DC. And last we will discuss about the null type instrument. So definition: in a null type instrument, the measured quantity is balanced or nullified by opposing quantity. The measurement is read based on the balancing condition. Here one, so suppose that here this is the balance balancing input. This is this is a known, and another is a unknown input that have to that measure that can be measured. So first by by providing the balance, we can achieve the null position, both of them. So working, we can discuss the working order. The output is null when measured variable match with the opposing references variable. Measured variable means known variable, measured value is unknown variable, measured variable matched करेगा, just matched with opposing reference variable. This means unknown variable. If both are equal, so that time we can get the null null position, so leading to a very high accuracy. So some example we will discuss about the null type instrument. First, we can use the Wheatstone bridge. Wheatstone bridge. Suppose that the structure of Wheatstone bridge like this. Hmm, suppose the structure of suppose that this is the one resistance, like this Wheatstone bridge. One resistance like this. One resistance like this. Here we are taking the output here. This is the positive terminal. So this is the power supply we are providing here. So one thing's a variable. So we have this is the arrangement of Wheatstone bridge R1, R2, R1 and R2. This type of arrangements we will discuss in later when we will see the application of this instrument. So the balance the voltage drop in a circuit according to the resistance. We will discuss about the balance condition of Wheatstone bridge. Then applications to use to measure the electrical resistance with high accuracy. When we need to measure the electrical resistance with very high accuracy, so we can use the Wheatstone bridge. Second, potentiometer. Compare unknown voltage with the standard references voltage to measure the voltage or EMF without drawing the current from the circuit. Those are Kelvin double bridge. The principle balance the resistance in low resistance measurement used for precise very low resistance, and very precisely we have to measure. That time we can use the Kelvin double. AC bridge balance the impedance in system. We can use the impedance in AC system, so measure the inductance, capacitance and impedance. That time we can use the AC bridge. Null balancing scale balance the mass or force against the non-standard analytical balance. For precise weight measurement we can null balancing scale. Optical null instrument use the light interferences pattern to achieve the null deflection to measure the distance and angle in metrology. And so right now what we have discussed, based on that we can comparison between the null type and deflection type. पहला based on the principle, पहला deflection proportional to input. If we are changing the input, that deflection directly proportional to deflection theta. In this instrument we can say deflection theta directly proportional to the input. What input? We can say directly proportional to input. In null position, here null balance is achieved. We have to achieve the null position. Principle it works principle based on the null balancing. First we can balance known quantity with unknown quantity. When they are equal, so that time we can get the null balance achieved. Accuracy, moderate deflection and null type accuracy is variable, because one time we have achieved the null position, so output is very accurate. This is the deflection time accuracy is moderate, because If sudden input changes, so and this deflection will change. So then again, its reading will different. Speed deflection type is faster because this is we can set we can measure very fast because there's no need to much more time. But null type is very slower because to getting the null position it is a required time. There's a complexity. Deflection is very simple. Relatively null position are relatively complex. Application like portable field instrument. Null type generally we can laboratory precise instrument. So today we have discussed different type of instrument. In next class we will discuss manually and automatic instrument. So for today this is sufficient. For next class we will discuss manually operated or automatic instrument. Thank you so much.